Alright guys, welcome to section 7.6, solving with the common log. Okay, the common log is log base 10. It's a pretty popular log base to use, so that's why they call it the common log. It's used a lot, so it's common. And it can be written with shorthand without the base 10 because it's used so common. Okay, mathematicians just get lazy and they said forget the little 10 on the bottom. Everyone knows what we're using here. So if you see just a log with no base on the bottom, we're talking log base 10, or the common log. And these are the calculator logs that we can do. Okay, find the log button on your calculator. Should be right here next to the 7. Or even on a regular scientific calculator. Okay, the log button's up here by the second key. Alright, so piece of cake. So if we're doing like log of 5, we just type that in, close them off, and there we go. Pretty easy stuff to do. Okay? So solving with the common log. Okay? We want to use this when both sides can't be written as the same base. So when we've seen problems like this before, we've wanted to rewrite them both as a power of 4. Okay, like 4 to the x, and then this is like a 16. So then we would say like 4 squared. All right. Let's get one that isn't written out already. Okay. But that's not always the case. Like 19, I can't rewrite 19 as a 4. I can't do 4 to the second or 4 to the third and get 19. Alright, so what we're going to need to do then is take the log of both sides. So I do the log of both sides, and that's going to help me because then I get to use my log properties, which allows me to bring exponents down in the front. So I get to take that x out of the exponent and put it down in front. So it's x times log of 4 equals log of 19. So x times log of 4, so how do you undo times? We divide both sides by log of 4. And there we go. We can just type this into the calculator now. Log 19 divided by log 4. Make sure you close your parentheses off. Oops. There we go. Ta-da! 2.12. And actually your book's going to want you to round to 4 decimal places, so this would be 2.123. Well, 2.1240. Okay? Alright, you try 5x equals 55. 5 to the x equals 55. Following that same pattern there, and I'll zoom out so you can kind of see both at the same time. Go ahead and pause and work that one out on your own. Okay, so here's what you should have. Log of both sides. Bring that x down in front. Divide by log of 5. And we should have 2.48, or probably some more decimals there if you went further. Okay, good start. A good start. Alright, so that's pretty much it for like concepts today. Now it's just being able to use that in a different aspect here with inequalities. And now it's going to have x on both sides. Okay? So don't panic when you see the x on both sides. It's just going to take us a little bit longer. It's going to have to be a little more detailed. It's not any harder, just a little lengthier work. Okay, so I can't rewrite 6 as a power of 3. So we're going to just do log of both sides. That's going to allow us to bring down the exponents. Alright, so my 2x comes down in the front. The x plus 1 comes down in the front. And if you have like a grouping of exponents up in the top, make sure those stay in parentheses when you bring them back down. Okay, now I have a parentheses times log of 6. So now we need to distribute this, and you can look at it 2 ways. We can look at it as I'm taking x times that and then 1 times that, or we can go the other way. Log of 6 times x and log of 6 times 1. Whichever way makes more sense to you, that's the way you should think about it. Okay, so I took x times log of 6 plus 1 times log of 6. Okay, so now we have x's on both sides, and it's looking pretty scary. Alright, think back to our normal algebra equation solving skills here. If we have x on both sides, we want to get all those x's on the same side. So we're going to subtract x times log of 6 from both sides, taking it off this side and putting it over here with that one. Okay? Now, a mistake kids are going to make is they're going to want to subtract these x's and then subtract like the log numbers. Okay, leave those two things completely separate for now. So it's 2x log of 3 minus x log of 6. Okay? And the point of getting both the x's on the same side, okay, and only things that have x's over here so that I could factor out the x. So we're going to factor out the x. So x goes in front of, now this is just 2 log of 3 minus log of 6. So I have x times this big group. Okay, how do you undo times? Opposite of multiplication is division. So we need to divide both sides by this big group. Okay. And since we're doing an inequality, we should make sure that that quantity is not negative. Let's see what 2 log of 3 minus log of 6 is. Because if it's negative, we just divide it by a negative number, and we need to flip our sign. It is not negative, so we get to leave our sign the same. So we have log of 6 divided by 2 log 3 minus log 6. Okay? And we should get 4.42. I'm going to show you how to type this in without getting lost here, because there's a lot of stuff going on, and we want to make sure that we're able to type this in right. So there's only one thing on the top, so that shouldn't be a problem. Log of 6. Divided by, now there's multiple things on the bottom, so after we hit divided by, we want to put a parentheses right away, because there's going to be a big group of stuff on the bottom. 2 log of 3 minus log of 6. Okay, and now I need to add another closed parenthesis to close up the one that I started right away at the very beginning. And we should get 4.4190, and I rounded it to 4.42 for this problem. Okay? So like I said, it's not too tough, it's just kind of long. Okay, it's all stuff we've done before, just now it's got a log in it, which is still just a number, and it's just a lot of steps. Very, very last thing, pretty easy thing. Okay, it's called the change of base. Alright, for any log base a of n, you can change the base to a more easily calculated base, such as the common log, log base 10. So we can quickly type it into our calculator by using this formula. Okay, log of your new base of your big number n over log of your new base of what was your old base a. So example, log base 3 of 11. Okay, it's easy to remember. The big number stays on top, little number goes on the bottom. So this is going to be, I changed it to log base 10, or the common log, just regular log. So this is log of 11 over log of 3, and I can type that into the calculator. Alright, and get the answer. Whereas if I just had it as log base 3 of 11, a lot of your calculators, you wouldn't be able to do that right away. Some of you guys have the fancy calculators that can. A lot of you don't. So even using this way, we could type it in with a good old scientific calculator. Right? We could do log of 11 divided by log of 3 and get the same answer, and now everybody's on an equal playing field. Okay? Go ahead and try that one if you want real quick. Hit pause and try this one real quick. Alright, and did you get, okay, log of 12 over log of 7? .27, well, that'll round up to 70. There you go, guys. Let's see. If you're watching this for part 1, 7.6 part 1, we're on page 495, 19 through 38, skip number 22. Okay, there were no new notes for part 2. I believe we're doing that one on accuracy, so that's page 495, 42 through 62 evens. So make sure you take your time on those. Alright guys, thanks for watching and we'll see you in class.